Hello everyone, welcome back to our Java programming series. In this session, we'll be diving into the very basics, starting with the essential Hello World program. This is a fundamental step for anyone learning a new programming language. And today, we'll not only write the program, but also dive into the nitty-gritty details of setting up your development environment. Let's get started. The Hello World program is a tradition in programming. It serves as a simple yet crucial introduction to the syntax and structure of programming language. Today, we'll not only write the program, but also go through the steps of setting up our development environment. Let's set up the environment by creating a new project in the selected Java IDE, which is IntelliJ IDEA. Here, by clicking on the new project, I will give our project a name, software test, since our intention is to create a project for software testing. Then in this wizard, you see location for your project, the language that you will be using, which is by default Java. The build system is set to be chosen from IntelliJ, Maven, and Gradle. By default, for ease of simplicity, for ease of pedagogy, we'll use IntelliJ. The selected JDK is JDK 21, so it depends on the latest version of JDK when you watch this video. If you want to generate sample code while creating this project, you can check the checkbox add sample code and generate code with onboarding tips option. So we need sample code, so I will check this option. So the sample code generated looks like this. Again, for ease of pedagogy, I will delete this section of the code and start by writing a program at the entry point that displays a hello world program. So for that, I will use a library system.out.println, and I will write a string literal hello world like this to verify the functionality of the IDE and the development environment. Now let's compile and run this program. You can right click and click on run main.main, or you can also click on this play or run button at the top of the menu bar. As you can see, we have a hello world result, which is the product or the output of this entry point, which is the main entry point, which is static type method generated by the IDE upon creation of the project. Let's modify the printed message. For instance, rather than hello world, I would like to say welcome to the Java class. So the corresponding result that will be displayed here resembles what we wrote there. As you can see here in the bottom section of the IDE, we are able to see the welcome to the Java class information, which is a result of the main method or the entry method in this class. So at this moment, you don't have to worry about the structure of this class, the semantics behind the name, the semantics behind the different access modifiers that I have used here, the return types, the name of the method, and also the arguments. Okay, you just simply have to know what I gave it to the what I gave to the function and what I got in the console section. In the next section of this lecture video, I'll talk about variables and data types. Now let's delve into the world of variables and data types. Understanding how to declare variables and work with different data types is fundamental to efficient programming. So let's jump in and explore these concepts together. Let's first start by defining variables. Variables are the building blocks of any program. It allows us to store and manipulate data. In Java, it's crucial to understand the data types for efficient programming. So now we will cover the basics of declaring variables, explore common data types, and perform some basic operations. Let's first start by declaring and initializing various variables. But before that, in order to declare a variable, that we have to now the data types available for Java. The common data types that we can use in Java are int, double, char, and boolean. But in general, we can also use different data types, which are different from the current ones, like byte type data type, short, long type data type, float type data type, can also be used while while declaring and initializing variables. So let's start by declaring some types of variables. So here, just for the ease of readability, I will put some comments. So comment, this is single line comment in Java. So I will say variables and data types here. And I can also use multi-line comments like this, okay? These are multi-line comments. That means we can use this kind of comments for multiple line documentation. So the first step in the section of variables is variable declaration. Okay. So we have multiple, data types. So when we say variable, it's like a placeholder with some memory location. Okay. But the type of data it can hold is expressed in terms of data type. So as I already mentioned, there are byte type, short type, int type, long type, float, double, character, boolean type, and many more user-defined type data types that you can declare or use to declare variables in Java. For instance, the first data type that we can use is integer type data type, which is int type. Let's say int a. Okay. This process is called variable declaration. Here we are simply assigning a memory location for an identifier named a, whose data type or domain is integer. That means this a can only hold values which is type integer. The other one would be double. Okay. Double, for instance, b. This is another initialization declaration. This process is called variable declaration. It's a process of assigning memory location to each identifier, which serves as a box for values that will be assigned in the process on the course of software development. So next, I will be writing initialization instructions for the declared variables above. So this comment generally helps you to increase or boost the readability of your code, the first thing, and later for code documentation, they have significant contribution. So initialization is all about assigning values that will be held by the identifiers that we have declared so far. So for instance, in the first part, we have integer type, for instance, a. So it could be 127, for instance, 127. It's integer, so it's doable again. B is float type or double type. So that means we can only assign, double type numbers, or any number we assign here will be restructured to double type. So let's say it's 10.5. C is for float. So float, the declaration for float is the same as double, but the initialization requires something the id. Okay, let's display the variables that we have initialized so far. Let's run the main method. As you can see in the console to the bottom left corner of the screen, we are able to see the welcome to the Java class string literal that we have published in the first part of this lecture, and also the byte, double, float, short, long, and character and Boolean equivalents that we have initialized in this exercise are also displayed. So this is basically how you can declare variables, various data type variables in Java, and how you can initialize and use them in the course of your program. So far, we covered the fundamental of declaring variables, initializing various data types, and how to use them. Now let's dive into the arithmetic operations. or in general operations that we can use in Java. We'll write Java code to perform basic arithmetic operations and experiment with different data types and closely observe the results. As a quick recap, arithmetic operations in Java include addition, subtraction, multiplication, division, and the modulus operation. These operations can be performed on numeric data types such as integer, double, float, or any other data types too. Today, we'll not only perform these operations, but also observe how the choice of the data type influences our results. Let's perform integer arithmetics in the first part of this session. So for ease of readability, I would like to cancel or comment this one out and assume we do have nothing here. Okay, we haven't initialized or declared any variables. I will start by initializing and declaring new variables for for this current experiment. Let's start by declaring and initializing new variables which are integer data type, because we are going to do integer arithmetic. Okay, so let's say we have int number 1, and let it have a value 10. At the end of every statement, you should use semicolon in Java. Okay, that should not be forgotten. Int number 2 shall be some number less than the first one, and let's declare a third variable, because I'm going to do sum between number 1 and number 2. So for that, I need some box to accept the result. I call it sum. So let's add number 1 plus number 2, semicolon. And let me display this one. So system.out.print or print line. When you say print, it displays the result without any new line. If you say print line, there will be a new line at the end of the first output. So here I would like to display sum, but before that I would like to write some label for it. Let's say it's total, and I use a concatenation operator. This concatenation operator concatenates as a string every result that you render to the console. So here I will say sum, and if you run this result, you will get the result for the sum of the two numbers. But before that, I think I've made the first number 1, number 2, it should be number 1. So the sum should be 10 plus 5, which is 15. Let's run it. That's a simple example for the addition operator, which is part of the arithmetic operator. Now let's reproduce the results that we get with this by using some more additional arithmetic operators. Let's use another one for multiplication. Let's use another variable product for number 1 times number 2. Okay, let's run this one. As you can see in the bottom left of your screen, we have got our results for the code executed. Total is set to be or calculated as 15, product is 50, quotient is 2, which is number 1 divided by number 2. The difference is for the subtraction of the last one is 10 minus 5, which is 5. Remainder, it's a remainder for dividing number 1 with number 2. So it is the division result is 2, the remainder value will be 0. There will be no number left. So this is how integer arithmetic could be performed by using these 5 operations: sum, product, quotient, difference, and remainder, or addition, subtraction, division, multiplication, and modulo. Let's start doing arithmetic for floating point arithmetic. So floating point arithmetic. So first, let's start by declaring double type numbers. Number 1, which is 10.0. Since it is double, I have to use this kind of format. The second one would be the number 2, which will have a value 5.0, with slight difference from the previous one. So now let's compute the arithmetics for this number. The first one would be double sum, which is equal to number 1 or number 2 plus number 1, like this. We'll have double product. Now let's display this result back to the console, or let's render this result back to the console and see how arithmetic integer operations are different from arithmetic floating point operations. As you can see in the left bottom corner of the screen, we have got results for the code executed, and all results have some things in common, which is all of them are in decimal point or fractional point or in double format. So this is the major difference. But to emphasize more on the difference between floating point arithmetics and integer arithmetics, let's see some more examples with mixed data types or by mixing data types. So for that, I will comment the previous codes out, and I will start declaring new variables for the purpose of this one. So I will be working on mixing data types to show you how arithmetic operations differ in terms of, or in the case of double or floating point, and in the case of integer. Let's start by declaring int num type or integer type variables, initializing them with some integer value and some other double type double num with a decimal point value. Let's say it's 5.0. Now let's compute mixed result with double type sum. Okay, with double type sum. So let's say double sum, double type double sum. I haven't written the data type of this variable. So double type double sum is int sum plus double sum. So what do you think will be the result of this statement? Let's see. So as you can see the result is a double type result. This is mainly due to the fact that the receiver variable here has a type double. So the corresponding result, which is represented by the double sum, will be double. So even though we have an operand which is a type of integer, the result will be set or casted implicitly to the data type of the receiver variable. This process in general is called implicit typecasting. Okay, implicit typecasting. So implicit typecasting basically is done by the compiler, So the other type of casting that should be done by the user is explicit casting. Okay, explicit casting or type casting. Here, rather than the compiler, you are responsible to cast your variables to the required domain. Let's see one result, for one example, for instance. Int number 1, let's say, is equal to 10. Okay, let's say int number 2 is equal to some value, or let it be double, for instance. Okay, double number 2, let it be 5.0. So I want to check whether the sum of this is computable or not. So let's say int sum is equal to number 1 plus number 2. So when I print this one with system.out.print, when I print sum, you will see the raise in compile time error. This is mainly due to the fact that the two variables you used here have different data type. So in such kind of conditions, you are required to explicitly cast the variable. So here we have a double type, so it should be casted to the smaller integer type data type, since the receiver sum is integer type. So int sum is equal to number 1 plus int number 2. That means casting number 2, which is double type, to integer type. So the result will be in integer format, since sum here is integer type. So rather than 15.0, we will get 15, which is integer value. So this process in general is called casting. That works for both float, char, byte, double, and any other data types. Okay, you can convert from one data type state of a variable to another data type state of a variable. So look, when we compute the sum of two operands here, one integer, one double, since the receiver has a larger domain than the integer one, it can handle the result that we get from this one. So for that purpose, it accepts without any explicit casting, or implicit casting works well with this case. But when you come to the second case, sum is integer type, and the capacity of num2, which is double type, is larger than integer type sum. So for that purpose, the compiler requires you to explicitly cast this one to integer type. So that way, it works well, and it will be explicitly casted to integer type. Now, let's widen our understanding in this domain by doing some exercises. So far, we have been discussing about variables, data types, and then basic arithmetic operations like addition, subtraction, multiplication, division, and modulo. Now let's raise some exercise questions and try to deal with it in a way increasing our understanding in this specific domain. So let the first exercise be an exercise to declare and initialize some variables with the data types that we have learned so far. So let me rewrite the question as declare and initialize variables of the following DTs, data types. Let the first one be int, then float, then double, char type, string type, and finally let it be a Boolean type, which is a type with two possible values. So to address the first one, for instance, if you want to declare and initialize a variable type int, you simply say int, you give it any random name. Usually the convention is that whenever you name your methods, variables, you should use very informant terms. So for that purpose, I would say for this specific part, val int or var int, I will assign it a random value, okay? The second one is float. Float, let's say, type var float, and its value is like 120.5 f. We already learned about this one, the need for f. The other one is, according to the exercise, the double type variable. Let's say it's 120.5, so we don't need to specify any qualifier. The other one is char. Char is a character type variable which you can hold on exactly a single character. Let it be a. The other one is a string. String var string. We can assign more than one values to string type variable because string is a list of characters, okay, basically. So I can say hello world, for instance. So it can be registered as a string or it can be stored as a string value. I think one thing that I might have forgotten is Boolean type variable. So I might say var bool, and its value could be true or false. So I prefer to set it as true. So this is an answer, a potential answer for the first exercise. Let's go to the second exercise. The second exercise is paraphrased as the following. It is mainly about implicit typecasting. So perform implicit typecasting for the following scenarios. Okay. So whenever I post this kind of exercises, I recommend you or advise you to pause and try it by yourself. So the scenarios is first to convert from int to double. Second scenario, to convert from char to int type, and let me add one more, to convert from int to string. So since we are talking about implicit typecasting, we don't really need to apply a casting phrases here. We simply have to declare a number and initialize it with a value which is different from the domain it's declared for. So to convert some number, integer number to double, I have to declare a double type value. Let's say var double 2, and let it be some number 120. So here, the compiler basically implicitly converts 120 to 120.0. This is what we call implicit casting. Okay. Okay. Then the second question is about converting char to int. For this, we have to declare int type variable var int2. Let it be var int2. And if I write, for instance, like this, then the compiler will implicitly convert this value to its ASCII equivalent. Okay, this is how implicit casting works for integer to or character to integer conversion. Okay, I have to comment this one. Third one in this exercise was about casting integer to string implicitly. So string, let's say var string 2 is equal to hello and like this. Hello, your age is, let it be like this. Then let me concatenate some integer here. So this will simply cast 10 to string. So if just to show you how the compiler treated it for the last scenario, let me print the value var string 2. As you can see in the left bottom corner, it is considered as a string because it says hello, your age is 10 at the end of the console. So it shows that the Java compiler implicitly casts such kind of things. So it's possible to cast from integer to string, character to integer, and also from integer to double implicitly. Okay, so implicit casting is possible in all these three scenarios. That being said about the implicit casting scenario, let me add some more exercises for explicit casting. Let's add one more exercise on explicit casting. Let me paraphrase it as perform explicit casting for the following scenarios. Okay. The first scenario, to cast explicitly from double to integer. Second scenario, to cast it from integer to character. And finally, let me add one more, to cast from string to integer. This is also a very simple exercise. So in order to cast from double to integer, first we need to have a double type variable. So for that, let's say var double3 be our new variable, and let me assign some value, like some random value for var double3. So in order to convert this into integer, let me declare an integer variable, which is int var int 3, let it be 3. And I will cast the double to integer by using this casting clause, okay? And the value var double3 will be used here. So this simply casts 15.6 into 15, like 15, because we are talking about integers here. The second scenario, to cast from integer to character, first I have to declare integer type value. So for that, let me say var int 4 is equal to, let's say it's 45, okay? Then to cast it to a character, I have to declare a character type variable, char var or varchar 3, okay, which is equal to the casting clause char of what? Var int, because we are going to cast integer type to character type. So this simply casts this integer into character type, The third exercise in this, the third question in this exercise was to cast from string to integer. So let me first declare string type variable like 3, and let it be equal to some value like number type value, because we are going to cast it to integer. Let it be 45. So we have to cast this one to integer. For that, I have to declare some integer value, which is int var int, let it be 5, I guess we do not have 5, is equal to integer dot %int, okay? %int will be used for string, and here I will put var string 3. This will cast var string 3 to var int 5 integer type. So to show you how it can render or how it can explicitly cast these values into their corresponding destination value or domain, let's display them one by one. As you can see here, the double2int was able to convert double type, which is 15.6 to 15. Into car was able to convert this one to, which is the value 45 to its ASCII equivalent, which is hyphen. A string to int was able to convert the string 45 to the integer 45. So this is how we can perform explicit casting. Let me add one more exercise before, two more exercises actually before adjourning this lecture. The fourth exercise here would be to perform mixed operations. Okay, we have already discussed about mixed operations. Mixed operations and observe results on the following scenarios. Okay, the first scenario, add int to double. Second scenario, add character to int. And third scenario, concatenation. Concatenate string to integer. For that, let's have each type of variables, each data type of variables for the mentioned variables. So for mixed operation, first we have to declare, let's say, num type whose value is some random number. Okay, and we will have double type value, which is to accept the result. And let me add this num, which is integer type, to some double type value. In the second case, I have already integer, so I have to add this integer to character type. So let me accept the result by second result variable. Then num plus with concatenation operator, because we only add integers with characters using concatenation operator. So let this one be b, for instance. And for the second case, let me have string type, which is result 3. And let me concatenate the integer with, let's say, the age is something like that, or something like that, plus num type. Let's display this by using the system.out.println and analyze the result. As you can see in the left bottom corner of this console, the first one returned 37.14 because the receiver variable is double type. When we come to the second one, since the receiver variable is integer type, then the character ASCII equivalent is converted and it is added to the current num value. So for that purpose, the 34 plus b, the current value of b is something like 66. So is added and yielded value 100. And in the last case, since the receiver is a string, then the string literal added with or concatenated with the integer yielded a string type value. So this shows how we can, use combined operations and how we can use the benefit of implicit casting and explicit casting in general. Let me add one more exercise to combine implicit casting with explicit casting. So show an example to show implicit casting with explicit one. Okay. For this, it's simple. Let me first declare a double type variable. Let's say double var 6. Okay, I'm naming them randomly. Let it have an equivalent value as pi. The second one, let it be variable int 7. Okay, then again, let it have integer type value. I would like to compute for the sum of these two, but I will use both implicit and explicit casting features. So for that, let me declare double result final, the final result in this lecture. And let me cast the double to integer first. Okay, for that we have already learned how to cast double to integer by using the int clause. Okay, double var 6 plus, sorry, plus the integer value, which is var int 7, right? Var int 7. So now let me display this one. What have I done here? Here we have a double type double var 6, which has a double value. And here we have a variable which is integer type with value 2. I'm planning to, my intention is to add these two numbers. But first, I am making or converting explicitly the double type to integer type. So at this moment, I will have a value 3 rather than 3.14 because I have already casted the double value into integer 1. Then 3 plus var int 7, which is 2, will be 5. I will have 5 at this moment. But assigning this 5 to double type result final will yield 5.0 because since result final is double, then every integer which is assigned to a double container or box or variable will have the characteristics of double variable. So for that purpose, I was able to get 5.0 as the result of this computation about the possibilities of implicit casting and explicit casting. Now let's talk about the impossibilities, the constraints that lets you or that abstains you from applying implicit casting and explicit casting. The first case would be the impossibility of casting primitive data types to larger types. But before experimenting these scenarios, let me comment everything out. So the first impossibilities, let me talk about impossibilities. Casting, mainly implicit casting. Okay? The first scenario would be to convert primitive data types to larger data types. Okay? So let me take one example, for instance. Int value is equal to, let's say, some random number. Then long value be the new long type variable. So implicit casting doesn't work for int value or to convert the int type value to long type value. So it's not possible to implicitly cast primitive data types like int to larger data types like. The second case would be about impossibilities to cast implicitly from floating point to integral point. So just to document it, floating point to integer point actually. Integer point implicit casting is not possible. Okay? Let's see by example. Let's declare double type, double value, let it have 3.14, okay? And let me declare integer type, which is int value, and let's assign the value of the previous one. So here the error says cast expression to int is required, okay? It's showing you how you should cast explicitly. So in this case, implicit casting doesn't work, okay? Doesn't work. So far, we have delved into the intricacies of arithmetic operations in Java, experimenting with data types, variables, and implicit and explicit casting. We have also experimented with some more exercises. In the next video, I will be talking about the remaining operations in Java.